Okay, this is the homework help video for Honors Math 3 Unit 5 Worksheet 2, and I'm going to start with question number 8. So these both have different irrational numbers. That's the square root of 50 versus the square root of 8. So that means I want to simplify both of these before I try to combine them. So I know that 50 is the same as 25 times 2. And 8 is the same as 4 times 2. So all I'm doing is breaking it up into numbers that multiply to 50, but one of them is a perfect square. And then numbers that multiply to 8, where one is a perfect square. So for here, I wouldn't use 5 and 10, because I can't square root 5 or 10. So then the square root of 25 is 5, but I already have an 11 there, so I'm going to do 11 times 5. And then I don't know the square root of 2, so I'm going to leave it as square root of 2. And then here, the square root of 4 is 2. And I don't know the square root of 2, so I will leave it. And then combine my coefficients. I'm going to add together 55 and 2. But I'm not going to add the radical, so it'll stay square root of 2. And if for this part right here, for the square root of 50, you don't like this method, you can always do a factor tree, right? So I could have got the same thing by using a factor tree. So for 50, 5 times 10, 2 times 5, and then I have a pair of 5s that I pulled out, so 11 times 5, with a 2 left over. Okay, so I can either do factor tree or try to do it mental math. Okay, so now I'm going to try number 14. So for this one here, so again, I'm going to do cube roots. So I know that for 16, I know the cube root of 8, so I'm going to rewrite 16 as 8 times 2. And then I know for 128, that's the same as 64 times 2. So this one you might not know, so you might want to do a factor tree on that one. And then minus 2, and then the cube root of 54 is 27 times 2. So again, I know my cube roots pretty well. So I know, like for example, 8 goes into 16. I know 64 is a cube root, and it goes into 128. And I know 27 is a cube root, and it goes into 54. So then I'm going to break it down. So the cube root of 8 is 2, but I don't know the cube root of 2. And then the cube root of 64 is 4, and then I already have a 5 here, so 5 times 4. And then I don't know the cube root of 2. And then the cube root of 27 is 3, and 3 times 2 is 6. And then I don't know the cube root of 2. And so these are all radical 2, right? All of these are cube root of 2, so that means I can combine them. So I'm going to add the front numbers together. So 2 plus 20, and then minus 6. So that's 22 minus 6, and then the cube root of 2. Okay, so again, if we don't like this, this way, we can always do factor tree, right? So I'll just do it on one of them, just kind of make sure. So like 128, for example. So I know 4 will go in there. So 4 into 12 is 3, and then 4 into 8 is 2. And then 32 is 4 times 8, and 4 is 2 times 2. And then 8 is 4 times 2, and then 2 times 2. So I'm looking for groups of 3, so there's 1 here, and then 1 there. So I have 2 groups of 3, so that would be 2 times 2 is 4. And then 4 times 5 is 20. So that's where I got the 20 from, and with the 2 left over, and the 2 left over. Okay. So again, you could either do factor tree or kind of like that guess and check idea. Okay, and then let's take a look at question number 20. So I want to do cube root, so I'm looking for numbers that divide evenly. So I'm just going to do all factor tree here so you can kind of see that method. So for 40, I could do 8 times 5. And then I'm looking for pairs of 3, or groups of 3. So I have a group of 3 here, and then nothing for that one. So I already have an x here, so I'm going to pull out that x just to the front. So for 40, I have a 2 and a 5 remaining. And then here, 3 goes into 4 one time with 1 left over. So 3 goes into 4, so I'm dividing when I have powers, factor tree with coefficients. So 3 goes into 4 once with 1 left over. And then I have 135, so I'm going to do that over here. So I know 5 goes into that. And then 27. So I have a group of 3 and then a 5 left over. So the 3 on the outside and 5 left over. It's kind of smushed in there. Okay. And then for the 7, so 3 goes into 7 twice with 1 left over. So now I'm going to put that together. So I have a 2x squared here, so I have x times x with that 2 out front. So 2x squared and the 3x squared. So I subtract the coefficient, so 2x squared minus 3x squared is negative 1x squared or negative x squared, and then leave the cube root alone. So it's kind of squished in there, but hopefully you can see that okay. Okay. And let's do one more, last one, 23. So here I'm going to just use distributive property. So I'm going to multiply this to both of these and this one to both of those. And so the 3 root 7 over here, so you multiply the rational part together, so 3 times 3 is 9. And then the square root of 7 times itself is just 7, right? That's the square root of 49, which is 7. And then now I'm going to multiply it over here. So we multiply the rational part together. So 3 times 5 is negative 15. And then root 7 has nothing to multiply to. And then now I'm going to multiply the 5 to both of these. So 5 over to here. So 5 multiplies to the rational number. So 5 times 3. And then root 7 has nothing to multiply to. And then finally 5 times negative 5. And then these are going to cancel because of 1 positive, 1 negative. And then 9 times 7. And then I just want to subtract those. So I'm going to do that over here. So 38. And then that's it.